बिस्मिल्लाह। Rahim. Assalamu alaikum students. I hope you are all fine and must have gone through the topic we discussed in our last lecture, that is the transportation model or the transportation method. Now let's class again. This is another illustration in which there are three sources of supply which are represented as S1, S2 and S3. There are three destinations, that is D1, D2 and D3, and the cost per unit cost from the different sources to the different destination is represented here in these cells. That is 2 rupees or $2 is the per unit cost if we supply a good from source S1 to destination D1. Similarly, per unit cost of transportation from source S1 to destination D2 is 4. So this is the per unit cost of transportation from a particular source to a particular destination, and the total demand for the different destination is again 10, 20 and 40 respectively. Again, the supply capacity on the part of the different sources is again given in this table. That is, the total capacity of source S1 is 15, source S2 is 25, source S3 is equal to 30, and if we sum up this capacity and demand on either sides of this row and column, we can have 70-70, which means that demand is also 70 and supply is also 70. So this is the case when demand is equal to supply. You must remember we discussed that there are three different cases in transportation problems, and one of the cases demand is equal to supply, the other one is if demand is less than supply, and the third case is if demand is greater than supply. So we'll also discuss the other two cases in our lectures, but today we are going to solve this particular problem in which demand is equal to supply. So class, again now we are to find out the initial solution, and here in this particular example we can use northwest corner method, and you already know that how we can use that method. Now this is the per unit cost is usually written in the upper right corner of a particular cell, and you can also put this cost in small square so that you can easily identify that this is your per unit cost. So first of all, in this initial method, by using northwest corner technique, we will have to find out the initial solution, and of course we will have to start from the very first cell, that is S1 D1, and again for this particular cell we will compare the row total, which is 15. We will compare the column total, that is 10, which is less 10. So we will put 10 in this particular cell. So when we will put 10 in this particular cell, it means the whole demand for the first definition is exhausted, and we cannot be able to add any other number in either of these cells, because we cannot disturb our total demand for a particular destination. Similarly, when we will add 10 here, the total supply of S1 will be reduced by 10, and then it will become 15 minus 10, that is 5. So this is the way we will fill the first column, and this is the procedure I just have explained you. So we have written 10 here, and this demand for the D1 destination is exhausted, so that's why we put 0 here. 0 means we cannot add any other number in this particular column, because we cannot disturb the total demand of destination D1. Now students, again we will move towards west. This is the west, that is S1 D2 cell. Then again for this particular cell we will again compare the row total as well as the column total. The column total is 20 and row total is 5. The minimum value is 5, so we will put 5 here. Again this row total will be exhausted, and this column total will be decreased by 5, and it will become 15. So this is again the method, and we will write 5 here, and accordingly we can reduce the demand and capacity of the particular supply S1. So again we will move northwise, and we will now fill this particular column. Again for this particular cell we will have to compare the row total, that is 25, column total, that is 15. The minimum value is 15, so we will write 15 here. Again the column total is exhausted, and we cannot add any other value in this particular column, and the row total will be decreased by 15, and now it will become 10. Now again we will move towards west for this particular cell, and again we will compare the row total, that is 10, column total, that is 40. So minimum value is 10, so we will put 10 here, and accordingly we will decrease the values in the row total as well as in the column total. So this is the last cell, and again the if we compare the row wise and the column wise, we have the similar value, that is 30, so we will put 30 here. So this is how we will fill the first initial table of transportation by using that northwest corner method. So again class, now this is the total demand and the total supply, and if we compare the row totals and the column totals, you can see that again the column total 10, this column total is 20, this column total is 40, 10 plus 5 15, 15 plus 10 25, and 30. So it means row total and the column total is not being disturbed, but through this method we have some initial plan of transportation. So what is this initial plan of transportation? That is, we can supply 10 units of goods from the source S1 to D1, then 5 units of goods from S1 to D2, 15 units from S2 to D2, 10 units from S2 to D3, and 30 units from S3 to D3, and accordingly we can find out the initial cost. Now how will we find out the initial cost? That is 10 multiplied by 2. 2 is the per unit cost. So if we supply 10 number of units, we will multiply 10 multiplied by 2, then again 5 multiplied by 4, 15 multiplied by 3, 10 multiplied by 7, 30 multiplied by 3, and we will add out all of these costs, so we can have the total cost for this particular transportation plan. So class, again you must remember that we have talked about a formula, that is m plus n minus 1, where m is the total number of sources or the number of rows, and n is the total number of columns or the total number of destinations. In this case m and n both are 3, so 3 plus 3 minus 1 is equal to 5. So this 5 indicates that at least 5 cells in our table should be filled. So you can see 1, 2, 3, 4, 5, these are the 5 cells which are filled, to which we have given some quantity, while the other cells are empty. Empty means there is no quantity being supplied to this particular cell for the time being, and we have written 0 here. You can always write the 0, or you can always remain this particular cell empty. So these are the empty cells actually. So 5 columns are filled, so we can use this particular method, and we can find out the values of the different variables. If our number of filled cells is less than this particular number, then again we cannot use directly this method. Then if the situation comes, then I will tell you that in that particular situation what we will do. So class, the basic cells or the basic variables are actually the occupied cells or the filled cells. So we can use the different terminologies: basic cells or the occupied cells or the filled cells, and the non-basic cells or the non-occupied cells or the empty cells. So these are the same thing. You can see that this one, this and this, these are filled cells, and the cells in red are unoccupied cells or the non-basic variables. So as we have just computed our cost for our first initial table by multiplying the each quantity supplied to a particular destination multiply by the relevant per unit cost. So this is our total cost for our initial transportation plan. Now again class, as a next step, we'll have to check out that whether this is the minimum cost or not. What we'll have to do, we'll have to find out the shadow cost, and we have already discussed the formula, that is Vij is equal to Ui plus Vj minus Cij. So by using that particular formula, we'll have to calculate the values of U and V. So what we will do, we can put that V1, V2 and V3 here, and U1, U2 and U3 here, where U represents the different rows and V1, V2 and V3 represents the different columns. So what we will do, we will make the different equations. That is, now this is the row u1 and this is the column v1. So we can make an equation that is u1 plus v1 is equal to this cost, that is the per unit cost at this particular cell, that is 2. So our first equation will be u1 plus v1 is equal to 2. Similarly, for this particular cell, our second equation may be u1 plus v2. This particular cell relates to column v2. So u1 plus v2 is equal to this particular unit cost, that is 4. So u1 plus v2 is equal to 4. Similarly, we can find out the values for this cell, and this one. So these are the different equations we have by comparing the relevant cells row wise and column wise, that is u and v. Now we'll have to find out the values of these variables, that is u1, u2, u3 and v1, v2, v3. And again class, we can use that particular rule that as in this particular case we have 6 variables, that is u1, v1, u2, v2, u3, v3. There are 6 variables and there are 5 equations. So 6 minus 5 is equal to 1. So it means that if we put the value of one variable to 0, we can easily find the values of the other variables. So we are putting u2 is equal to 0 in this particular equation. So if we put u2 is equal to 0, if u2 is equal to 0, then of course v2 will be equal to 3. So this is v2, which is equal to 3. And if we put the value of v2 here, the value of u2, okay, if we put the value of v2 here in this particular equation, the value of u1 will become 1. So that's why u1 is equal to 1. So in this way, by putting the relevant values in these equations, we can find out the values of u1, v1, u2, v2 and u3, v3. So these are the different values of these variables. Now what we will do, we will put these values here, u1 is equal to this, u2 is equal to this, u3 is equal to this, v1, v2 and v3. The relevant values are put in this particular table. Now class, as a next step, we'll have to find out the values of shadow cost for the different occupied cells. And as I told you that usually we do not calculate the shadow cost for the occupied cells, because the shadow cost for the occupied cells will be 0. Let's see this particular situation. Now this is the occupied cells, and if we use that formula for the shadow cost, that is Vij is equal to Ui plus Vj for this particular cell, that is S1 D1 for this occupied cell. So V11, again 1 means first row, first column, that is S1 D1 cell is equal to U1 plus V1 minus C11. Now this C11 is the per unit cost for this cell, that is 2. So value of U1 and V1 we have already calculated. U1 is equal to 1, V1 is equal to 1. So 1 plus 1 minus 2 will be equal to 0. So it means that the shadow cost for the occupied cells will be 0. So that's why we will not calculate the shadow cost for the occupied cells, and we are just interested in the shadow cost of the non-occupied cells. So let's calculate the shadow cost for this particular cell S1D3, which is the non-occupied cells, unfilled cells, or the non-basic cells actually. So again class, we will use the same formula, that is V13. Again this S1D3 cell represents first row, third column. So that is V13 is equal to U1 plus V3 minus C13, that is again the per unit cost, that is 3. That is written on the upper right corner, 3. So 1, if we put the values of U1 and V3, that is 1 and 7, 1 plus 7 minus 3, it will become equal to 5. So 5 is the shadow cost, and you can always write this shadow cost in the upper left corner. So you should have to write all of these costs in a manner that you can easily identify that what is the per unit cost, what is the shadow cost, and what is the particular amount to be transported in a particular cell. So in the same fashion, we will calculate the shadow cost for the all other non-basic variables or the unoccupied cells. For example, for the cell S2D1, this one, how we will calculate the shadow cost, that is U2 plus V1, that is 0 plus 1 minus this unit cost. So 1 minus 5 will be equal to minus 4. So this is the shadow cost minus 4 for this particular cell. Again, for this cell S3D1, the shadow cost is minus 11. How it is minus 11? That is U3 plus V1, that is minus 4 plus 1 minus 3 minus 8. So it will become 11. Similarly, the shadow cost for the S3D2 cell is minus 8. So again, the students, for the condition of optimality, we are interested in the negative shadow cost for the different non-occupied cells. But from this particular table, you can see that there is a shadow cost which is positive for this cell S1D3. So we will have to use that method of theta in order to find out the next table. Our criteria of optimality is non-positivity of the shadow cost, which is not satisfied, as we have S1D3 box with positive shadow cost. So we will use theta. Now again, class, I told you about the different looping method, that first of all we will consider the particular cell for which our shadow cost is positive. If the shadow cost is positive for more than one cell, then again we will select that cell with the highest positive value. But in this particular case, there is only one value of the shadow cost which is positive. So we will add any arbitrary value theta in this particular cell. Theta is to be determined, that what is the value of theta. So this method is being adopted actually to calculate the value of that arbitrary number represented as theta. So class, as you know that we cannot disturb our row totals and the column totals. So if we add plus theta here in this particular cell, we will have to subtract minus theta from this cell, and again in order to balance this particular row, we will have to add this theta in this particular cell, and again in order to balance this particular column, we will have to subtract theta from this particular cell. So this will become a sort of loop, that is plus theta minus theta plus theta minus theta. Now as a next step, what we will have to do, we will have to find the value of theta, and in order to find the value of theta, we will see in this particular loop that where the theta is being subtracted. You can see that the theta is being subtracted in this particular cell, that is 5 minus theta, and in this particular cell, that is 10 minus theta. So there are the two numbers, that is 5 and 10. Out of these two numbers, the minimum valued number will be actually theta. So again, this is the procedure, that is what we have done in this particular step, that we have add theta in the cell having largest positive shadow cost. This will disturb the row and column balances, for which you will have to add and subtract theta from some other cell. So I've just explained you this method. So again, in that particular loop, class, we have two numbers 5 and 10, and minimum of these two numbers is 5. So actually we will have to add 5 in that particular loop. So what we will do, this is the loop, we will have to add 5 in this particular cell. Initially in this table, we are not supplying any goods in this particular cell, that is 0, but after calculating that theta, we will add 5 here, because theta is equal to 5. Similarly, here we are transporting 10 number of goods, but now after incorporating that loop, we will less this number by 5, so it will become 10 minus 5. In this particular cell, again we will add that theta, it will become 15 plus 5, that is 20, and again in this particular cell, again we will minus the particular value of theta, that is 5, so 5 minus 5 will become 0. So this will become empty in this particular case. So again we will have to rewrite this table in order to incorporate that value of theta. So class, this is our new table, and you can see that we have incorporated that value of theta in this particular loop. So again, we'll have to find out the shadow cost by finding the same rules as discussed above, but let us calculate the total cost in this particular transportation model. You can see now in this particular table, if we are supplying the 10 particular goods from S1 to D1, then the total cost for this particular route will be 10 multiplied by 2. Similarly, if we supply 5 units from S1 to D3, the particular cost for this particular cell will be 5 multiplied by 3, and same is true for the other cells. If we add up all of these costs, then it will become 220. So you can see, class, in this particular case the cost has been decreased. Previously our initial cost was 245, but now it has been decreased up to 220. So the cost has been decreased. Now again, what we will have to do, we'll have to again find out the shadow cost, and again to find out the shadow cost we'll have to find out the first formulate the different equations, and then we'll have to find out the values of that variables, that is u1 v1, u2 v2 and u3 v3. So again we'll have to compute this equations, that is u1 u2 u3 representing the different rows, v1 v2 v3 representing the different columns. Again our equations will become as u1 plus v1 is equal to 2, that is the per unit cost. So again u2 plus v3 will be equal to 3. This is the next equation. So again, one by one, if we compare this u and v with the per unit cost, we will have these different equations. Now again, in order to find the values of these variables, let's u2 is equal to 0. If we put u2 is equal to 0 in these equations, we can find out the values of the different variables, that is u1 is equal to -4, v1 is equal to 6, u2 is equal to 0, v2 is equal to 3, u3 -4, and v3 is equal to 7. So class, again we have written those values of the different variables here in the particular cells, that is u1 is equal to -4, u2 is equal to 0, u3 is equal to -4, v1 6, v2 3, and v3 is equal to 7. Now again, what we will have to do, we'll have to find out the shadow cost for the non-occupied cells or the non-basic cells, because our criteria of optimality is non-positivity of the shadow cost, which is not being satisfied here in this particular situation. Now why it is not being satisfied? Because all the shadow cost for the non-occupied cells is not positive. There is still a positive shadow cost for this particular cell S2D1. Now again class, I will repeat here that how we calculated this shadow cost. We will use the formula of ui plus vi minus cij. So u1 here is -4 and v2 here is 3. So -4 plus 3 is -1, -1 minus this cost for this particular cell is 4. So -1 minus 4, it will become -5. Similarly, the shadow cost for this particular cell is u2 plus v1 minus relevant cost of 5. So u2 is equal to 0, v1 is equal to 6. So 0 plus 6 minus 5, that is the cost. So 6 minus 5 will be equal to 1. Similarly, the shadow cost -6 for this particular cell has been computed, that is u3 is equal to -4, v1 is equal to 6. So -4 plus 6, 2 minus 8, this will become -6. So this is the shadow cost for this particular cell. Again, the shadow cost for this cell S3D2 is -8, that is -4 plus 3, this is -1, -1 minus 7, that is the cost of this particular cell. So -1 minus 7 will become -8. So you can see that there are 3 shadow costs which are negative, but still there is a shadow cost for this particular cell S2D1 which is positive. So again we'll have to repeat this particular step, because our optimal solution will only be achieved if we are able to have that negative shadow cost for all of our non-occupied cells. So class, let's again repeat this step. Again we will repeat the step of finding out the theta value, and again class, let's suppose for this particular cell for which the shadow cost is positive, if we add theta to this particular cell, we will have to subtract theta from this particular cell, that is S2 D3. Okay class, there is a very important point to be noted here, that we didn't subtract theta from this particular column S2 D2 because if we subtract theta from this particular column, we'll have to add theta either in this column and in this column, which are both empty columns. So whenever we are making these loops, we always try to avoid empty cells for to be included in the particular loop. So if you can make a loop avoiding these unoccupied cells, so that is always good, and that will always give you the true results. But in certain situations, sometimes we will have to add some value in these empty cells, but we can never subtract theta or subtract any other value from these empty cells, because that is not logical. This cell is always because this cell is already empty, and we cannot subtract from an empty cell. So it is always good to avoid the empty cells for including that theta. So that's why we put plus theta here, and then in order to balance that particular row, we have subtracted minus theta here, and again in order to balance the column wise total, we will have to add plus theta here in this particular column. Again, in order to balance this particular row, we'll have to subtract theta here. So this will become a sort of closed loop. Again, in this closed loop, we will find out the cells in which theta is being subtracted. You can see that this S1 D1 is the cell, and S2 D3 is the cell in which theta is subtracted. There are two values involved in these particular cells, that is 5 and 10. Out of these two values, the minimum value will be r theta. So in this particular case, r theta will be equal to 5. So what we will do in the next step, we will just subtract 5 from these amount, that is 10 minus 5. Here in the next step, the quantity will be 5. Similarly, in this particular step, 5 plus theta, that is 5, it will become 10. In this cell 5 minus 5, it will become empty or 0, and again 0 plus theta in this cell S2 D1, it will become 0 plus 5, that is 5. All the other cells will remain same. So we will just change the values in that particular loop by incorporating the value of theta. So this is our theta, that is 5, and after incorporating that value of theta, this is our new table, students. Again, students will have to find out the shadow cost, that whether this table will give us the optimal solution or not. So again, we'll have to put that U1, U2, U3 in different rows, and V1, V2, V3 for the different columns. And again, we'll have to make the different equations. That is again the equation U1 plus V1 is equal to this particular per unit cost, that is 2. So first equation will be U1 plus V1 is equal to 2. Second equation will become U1 plus V3 is equal to 3. So we only formulate these equations for the occupied cells. It is again a very important point to be noted. We formulate these equations for the occupied cells. So these are the different equations, and this is our total cost for our last plan, that is again 5 multiplied by 2 plus 10 multiplied by 3, 20 multiplied by 3 plus 30 multiplied by 3 plus 5 multiplied by 5. So if we add up all of these costs, so it will become 215, and you can always see that in this particular plan the cost has been reduced from our previous total value of cost. So next again class, we will have to put the value of any of these variable to 0. So if we put U2 is equal to 0, we can find out the values of the other variables, and the values of these variables will become U1 is equal to minus 3, V1 is equal to 5, V2 is equal to 3, U3 is equal to 3, and again V3 is equal to 6. So by using these equations, what we can do, we can find out the shadow cost for the non-occupied cells. Now this is the non-occupied cell. Again, non-occupied cells means non-basic cells or the empty cell. This is empty because there is no good is being yet transported for this particular cell. So that's why this is the empty cell. So U1, again, we will use again the same formula class, that is Ui plus Vj minus Cij. Cij is the per unit cost for the relevant cell. So again U1 plus V2, the relevant column, minus this cost, that is 4. So here U1 is equal to minus 3 plus 3 will become 0. So 0 minus 4, that is the cost, this will become minus 4. So this is the shadow cost for this particular cell S1 D2. Again class, we will calculate the shadow cost for this empty cell. This will become U2 plus V3, that is 0 plus 6 minus 7, it will become minus 7. So again class, the shadow cost for this particular cell S3 D1 is 0, that is U3 plus V1, that is 3 plus 5 minus per unit cost, that is 8. So 8 minus 8 will be equal to 0. All the shadow costs are non-positive or negative, which is the indication of optimal solution. You can see that all the shadow costs are either negative or 0. So this is the table which can give us the optimal solution. So this is our optimal solution, that is, we'll have to supply 5 units of products from S1 to D1, and of course the total cost for this particular route will be 5 multiplied by 2. Again, we can supply 10 products from S1 to D3, and the particular cost for this particular route will be 10 multiplied by 3. We can supply 20 products from source S2 to destination D2, and cost for this particular route will be 20 multiplied by 3. And again we can supply 30 units from source S3 to destination D3, and the total cost for this particular unit will be 30 multiplied by 3. So we can always add up this cost, and the total cost will become as 215. So class, this is the particular route of transportation through which we will be able to minimize our total cost. So this is again we have so again class, we have solved this particular question by using that MODI method, and again we can also solve this particular question by using the other method, that is stepping stone method. So let's solve this particular question by using that stepping stone method. Again class, let me draw this table. These are the different sources. Sources of supply actually S1, S2, S3, and their relevant supply capacity is 15, 25 and 30. And these are the different destinations: D1, D2, D3, and the relevant demand of the particular destination is 10, 20 and 40. So demand and supply in this particular case are equal, that is 70 and this is 70. So here this is the supply and here this is the demand. Similarly, we can always write that per unit cost in the small squares, that is 2, 4 and 3. 2, 4, 3, then 5, 3 and 7, 5, 3, 7, 8, 7 and 3, 8, 7 and 3. So class, this is the same question we have just solved through that MODI method, but now we are going to solve this particular question by using that stepping stone method. So first of all, we'll have to find out the initial solution. So let's suppose we are using that northwest cost let's suppose we are using that northwest corner method. So if we use this particular method, what we will do, we'll have to start from this particular cell, compare the row total and the column total. What is the minimum value? That is the 10. So we will write 10 here. Now this column total is full, and now here the 5 still remains. So the 5 here and 20 here, the minimum value is 5. So we will write 5 here. Now this total supply has been also fulfilled. So again, here still the 15 difference remains. So we will write 15 here. Now this column total is also filled. Now we will move towards our west. Then we can write 10 here in order to fill this row total. Then again we can write 30 here. So we use that northwest method in order to fill this particular table, and you should have checked this total, that this is 10, this is 20, this is 40, row total 10 plus 5 15, 15 plus 10 25, and 30 is equal to 30. So it means your row total and your column total is not being disturbed. So we can find out our initial cost from this table. Our initial cost will be equal to 10 multiplied by 2. 10 multiplied by 2. Now 10 means we are supplying 10 units in this particular plan, and per unit cost of our product is 2. So we will multiply 10 by 2 in order to have the total cost for this particular route, that is S1 to D1, plus 5 multiplied by 4. 5 multiplied by 4 plus 15 multiplied by 3. 15 multiplied by 3 plus 30 multiplied by 3. Plus still a cell remains here, that is 10 multiplied by 7. 10 multiplied by 7, that is the cost for this particular cell which I missed, that is S2 to D3. So we have calculated the total cost for all of the occupied cells. Now 10 multiplied by 220 plus 5 for the 20 plus 15 3 the 45, 30 multiplied by 390, and 10 multiplied by 7, it will become 70. So let me total all of these amounts, that is 40 plus 45 plus 90 plus 70. This will become 245. So this is our total cost, that is 245. So class, we have find out the initial cost from this particular table. Now we'll have to check out whether this cost is optimal or not. So if you recall the method of improvement indices, you must remember that whenever we use that stepping stone method, then we compute the improvement indices for the different unoccupied cells. So let's compute the improvement indices for the different unoccupied cells. So class, the first unoccupied cell or the empty cell is S1 to D3. This may be represented as S1 to D3. So how we will calculate this improvement indices? We have already done a related problem, that if we add one unit, if we are supposing that if we add one particular unit at this particular cell, then what we'll have to do? We'll have to subtract that particular unit from the next cell. Similarly, if we subtract one unit here, we'll have to add the unit here, and again we'll have to subtract the unit here in order to meet the row total and the column total equal. So if we are adding one unit here in this particular cell, so it will become 3. We'll have to bear the extra cost, that is the extra per unit cost, which is 3. So 3. And if we subtract that unit from this particular cell, then again the per unit cost will be subtracted, that is 3 minus 7. Then again plus 3 and minus 4, and it will become 3 plus 3, 6 minus 11. This will become minus 5. So class, this is a particular loop for this particular empty cell. This is the particular loop for which we have calculated that improvement indices. So let me draw this loop so you can easily identify about this particular loop. This is the loop. This is the particular loop for this particular empty cell. So class, again the next empty cell is S2 to D1. S2 to D1, this is empty cell. Now again we will have to repeat the same procedure here. If we add one unit here, so we'll have to add 5 here. 5 minus 3 plus 4 minus 2. So it will become 5 plus 4, 9 minus 5, that will become 4. So this will become 4 here. Next empty cell is in this particular case S3 to D1. S3 to D1. Now again class, S3 to D1, if we add one unit here, we'll have to bear extra cost, which is equal to 8. Now again class, the particular root for this particular empty cell, if we add something here in this particular cell, we cannot subtract that value here in this empty cell, because this cell is already empty and we cannot subtract anything from an empty cell. So what we will do, we will subtract that particular value from this particular cell. And again, in order to balance this column row, and again in order to balance this column total, we will have to subtract this particular value from this particular cell. We'll have to subtract that value here, and again in order to balance this row total, we will have to subtract that particular value from this particular cell. So again it will become a sort of loop. So this is a loop for this particular empty cell S3 to D1. So we will add 8 minus 3 plus 3 minus 2. So it will become 8 plus 3, 11 minus 5. It will be equal to 6 in this particular case. There is another empty cell class that is the S3 to D2. S3 to D2, and again the loop for this particular cell S3 to D2, that will be again 7 minus 3, 7 minus 3. So this is the closed loop, 7 minus 3 plus 7 minus 3. This is the loop for this particular cell, 7 minus 3 plus 7 minus 3. So it will become 7 plus 7, 14 minus 6, it will become 8. So these are the improvement indices for all of our empty cells for this particular table. And again, what is the condition of optimality? Again, if you recall the previous lecture, I told you that all of these improvement indices should be positive. But in this particular case, you can see that this particular value is negative. So what we will have to do, we'll have to again use that method of theta. You can see that S1 to D3, the loop for S1 to D3 was 3 minus 7 plus 3 minus 4. Now suppose that particular value is theta, which is going to be subtracted and added in this particular loop. Now now class, again suppose this is theta which is being added here in this particular column. We'll have to subtract theta here plus theta here, and again minus theta here. Now this is the loop, the same loop which we have just computed, but we have introduced the theta here. Now again, in order to find out the value of theta, we will have to see that in which cell we are subtracting the theta. You can see that we are subtracting theta out of two of these cells, that is this one S1 D2 and this one, that is S2 D3. There are the two values involved in this particular cell, that is 5 and 10. The minimum value will be our theta. So there are two values in this particular case, that is 5 and 10, and theta will be equal to the minimum of these two values. So theta will be equal to 5 in this particular case. Now class, what we will do, we will redraw this table, and we will incorporate that value of theta in that particular loop only, and the remaining cell values will remain same. And that is here the initial quantity was 5, so we will minus theta here, that is 5 minus 5, it will become 0, that is empty. And again we will add 5 here, it will become 5. Here there is already 10, we will subtract theta, that is 5, 10 minus 5 will become 5, and again we will add theta, that is 5. Here in this particular cell it will become 15 plus 5 is equal to 20. So we will again redraw this table, and we will incorporate this value of theta in this particular loop. Students, let me redraw the table again. So students, I have redrawn that particular table, and now I will write down the quantity in the particular cell, and of course I will have to incorporate the value of theta as well. Now this cell will remain unchanged, so it will have 10. This cell was initially filled, but now it will become empty because we are subtracting the value of theta from this particular cell, and this in this particular cell we have added the theta, so now it will become 15. Similarly, in this particular cell, this will become again empty and it will become 20, and this particular cell will remain unchanged, and it will become 30. So class, we have refilled this table by incorporating the value of theta. Now let's check the total. This is 10, this is 20, this is 5 plus 5 plus 30, 40, then 10 plus 5, 15, then 20 plus 5, 25, then 30 is equal to 30. So it means our row total and column totals are not being disturbing. So again, we'll have to calculate the cost for this particular transportation plan, and here in this particular case the cost will be 10 multiplied by 2, that is for this particular cell, plus 5 multiplied by 3, then plus 20 multiplied by 3, plus 5 multiplied by 7, plus 30 multiplied by 3. It will become 20 plus 15 plus 60 plus 35 plus 90. So let's have a total of this particular cost, that is 20 plus 15 plus 60 plus 35 plus 90. Now this will be equal to 220. So this cost is 220. Now class, you have noted that our cost has been reduced. But again, we'll have to check out that whether it is the optimal cost or not. Is it optimal? Again, we'll have to find out the improvement indices. Again, the improvement indices for the unoccupied cells. Now in this particular cell, now in this particular case, the unoccupied cell is S1 to D2, S1 to D2, let's calculate the improvement index for this particular cell. So you can see that if we add something here, we'll have to subtract here, we'll have to add here, we'll have to subtract here. So the loop will become 4 minus 3 plus 7 minus 3 plus 7 minus 3. So it will become 7 plus 4, 11 minus 6 is equal to 5. Again, the next empty cell in this particular case is S2 to D1. So S2 to D1 class. Again, if we add something here, what we will have to do, we'll have to subtract. We can subtract here, but we will not subtract here class. Why we will not subtract here? Because in order to balance this particular column, there are two empty cells. So you remember I told you that we always avoid to fill the empty cells in order to make a loop. So what we can do, we can have this sort of loop, like we can add here, then we can subtract here in this particular cell, we can add here, and we can subtract here in this particular cell. So this will be our loop for this particular cell. So class, this can be our loop for this particular cell. So if we use this loop, it will become 5 minus 7 plus 3 minus 2. That is the per unit cost for this loop. So it will become 5 plus 3, 8 minus 9. It will become minus 1. So this value is minus 1. Again, the next empty cell is S3 to D1. D1. Again class, S3 to D1. What we can do, we can add here. This column is this cell is empty, so we will have to subtract from this particular cell. Again, we can move toward this cell and then this cell. So this is the closed loop for S3 to D1. So it will become 8 minus 3 plus 3 and minus 2. 8 plus 3, 11 minus 5, it will become 6. So next improvement index for S3 to D2. S3 to D2. Now S3 to D2, we can add here, we can subtract here, again add. No. For this particular cell, we can add here in this particular cell, we can subtract here, we can add here, and we can subtract here. So this will be the closed loop for this particular cell. So it will become 7. That is again the unit cost where we are adding a proposed unit. 7 minus 3 plus 7 and minus 3. So it will become 14 minus 6, it will become 8. Now class, again we have computed the improvement indices for all of the unoccupied cells, and again you can see that still there is one improvement index which is in negative. So it means that we can further reduce the cost, and we'll have to again use that theta method in order to calculate the value of theta. Now let's see the loop for this particular cell, that is S2 to D1. S2 to D1. So this is the loop for S2 to D1, and you can see that and you can see if this in this particular loop, if we add theta here, we'll have to subtract theta here, again we'll have to add theta here, and we'll have to subtract theta here. So this is the closed loop, and you can see the value where the theta is minus, that is the cells where we are subtracting the theta, contains two values again, that is 5 and 10. Again we have two values class, 5 and 10 in this particular loop. where we are subtracting theta, and again you already know that theta will be the minimum value out of these two values, so our theta will be 5. So what we will do in the next table, we will subtract 5 from 10 here in this particular cell, we will add 5 in this particular cell, we will subtract 5 in this particular cell, and it will become empty, and again we will add, 5 in this particular cell. So let's class make the table again. So class, we have read on that particular table. Now we'll have to write down the values by incorporating theta in the loop. So our new table will become 5 here, there will be 10 here, and 5 here, then 20 here, then 30 here. So what we have done, we have incorporated the value of theta and in that particular loop, and all the other values other than that loop will remain same. So this is our final table. Again, let's check the total of rows and columns. This is 10, this is 20, this is 40, 5 plus 10 15, 5 plus 20 25, 30. So row total and the column total are equal, so it means we are not doing any mistake. So again, for this particular cell, we'll have to calculate the total cost. What will be the total cost? That is 5 multiplied by 2 plus 10 multiplied by 3 plus 20 plus 5 multiplied by 5 plus 20 multiplied by 3 plus 30 multiplied by 3. So it will become 10 plus 30 plus 25 plus 60 plus 90. So 10 plus 30 40 plus 25 plus 60 plus 90. It will become 215. Now again class, you have noted that our total cost has further been reduced. Now again we'll have to check whether this is optimal or not. Is it the optimal cost? So again we'll have to find out those improvement indices. For the non-occupied cells, now the first non-occupied cell is S1 to D2. S1 to D2. Now let's calculate the value for the improvement index. Now you can see that if we add 1 unit here, we'll have to subtract 1 unit here, adding here and subtracting here. This will be the closed loop for this particular cell. So 4 minus 3 plus 5 and minus 2. It will become 4 plus 5, 9 minus 5, it will become equal to 4. Next empty cell is S2 to D3. S2 to D3. So class, if we add any unit here, what we will have to do, we can subtract here, again we can add here, and we can subtract here. We cannot go below, because in this particular row all the other rows are empty, so we always try to avoid these empty rows to be included in a particular loop. So what we will do for this particular loop, we will add here. So we will add here, this will be the loop. So class, this will be the closed loop for this particular cell, that is adding here, subtracting here, adding here and subtracting here. So the loop for this particular cell will become 7 minus 3 plus 2 minus 5. 7 plus 2, 9 minus 8, it will become 1. Now let's calculate the improvement index for the next empty cell, that is S3 to D1. S3 to D1. So if we add some quantity here, we cannot subtract here because of that empty cell, and of course we cannot subtract from the empty cell. So what we can do, if we add some quantity here, we can subtract this similar quantity here, and then again we can avoid that empty cell. We can move here and we can add that quantity here, and again in order to balance this row total, we can subtract that particular quantity here. So this will be the loop for this so this will be the loop from S3 to D1. So let's write its values, that is 8 minus 3 plus 3 minus 2. So it will become 11 minus 5, that is equal to 6. So this is the improvement index from S3 to D1. There is another empty cell, that is S3 to D2. S3 to D2. Now class, let's see the loop for this particular cell, that is S3 to D2. If we add some particular quantity here in this cell, then we'll have to subtract that particular quantity here in order to make balance of row total. So we'll have to subtract here. Now we cannot move in this particular cell. What we will have to do, we will have to move into this particular cell, and again we'll have to add that particular quantity here, and then again we cannot move in this cell. We will have to move in this particular cell, and again we'll have to subtract that particular quantity here. Now in order to balance this particular column, we will have to move in this particular cell, and again to balance this particular row, we'll have to move in this particular cell, and so the loop is completed for this particular cell. So if we incorporate this particular row, loop, its value will become 7 minus 3 plus 3 minus 2 plus 5 minus 3. So this is a particular loop for this particular cell. 7 plus 3, 10 plus 5, 15, minus 3, 12, minus 2, 10, minus 3, 7. So this will be the final quantity of improvement index for the cell S3 to D2. Now class, as you have seen that we have computed the improvement indices for all of the empty cells, and you can see that all of these empty and you can see that all of these improvement indices are positive. So it means our condition of optimality is being satisfied here. And what is the minimum cost? This will be the minimum cost. So this will be our minimum cost. And again, what will be the transportation plan? We can transport 5 units from S1 to D1, 10 units from S1 to D3, 5 units from S2 to D1, 20 units from S2 to D2, and 30 units from S3 to D3. So all of the demand will be fulfilled, and also our total cost will be minimized, and this will be the value of our total cost, that is 215. So class, you have seen that in today's lecture we have used the two methods, that is stepping stone method and MODI method, in order to find the minimum transportation cost in this particular case. So now you must be aware that how we can use these two methods to minimize the transportation cost. In the next lecture we will try to see the cases that what happens if the demand exceeds supply or supply exceeds demand. So these will be the cases we will discuss in the next lecture.